right, so in this video, we're going to go through multiple radicals. In the previous one, we only had a single radical. In the equations here, you can clearly see we have multiples. We have two in this case. So basically what's going to happen is you're going to repeat the process. If I had a single radical, I raise it to that power once and solve the remaining problem. Here, I'm going to have to repeat that raising process twice because there's two. Important thing to be aware of when you're doing this, you have to pick one radical to get by itself. If they were identical, then you could combine them, but these are not. You can clearly see they have different radicands on the inside. So we just pick one, get it by itself, go through the process of raising it to a power, and then repeat it with the second one. So here, I'm going to choose to keep the one that's on the right side already by itself. There's no need to move anything. It's alone. So I can start my process. It's a square root. So I'm going to square it. And we know that the square and the square root are going to cancel. Now, on the left-hand side, we don't have that case. I can't cancel out the radical because I have this 2 minus part in front of it. So remember, a square means there's two of them. So I can write this twice. And then I'm going to just FOIL the problem. And again, we know that the right side dropped out. So in the FOILing process, first, so 2 times 2, that's 4. 2 times the radical. No matter what the radical is, you treat it like a variable. So I know it's going to be a negative because it's 2 times a negative radical. So it's -2 times that radical. Then you move to the next part. So I'm going to do the radical times 2. So that's another -2 times the radical. And then I have a negative radical times a negative radical. So that's a positive radical squared. Right, timesing it by itself. From here, again, I can bring down that right side. I know the radical and the square are going to cancel. So that part's already nice and easy. I can drop everything out and combine my like terms. So -2 and a -2 radical gives me a -4 radical. And then +9 minus r equals -3 minus r. From here, you can combine your like terms and move everything over. So I'm going to kind of do it all in one just for space. I have 4 and 9, that's 13. So I'm going to subtract 13 from this side, and I'm going to add the r to get that one away. So these all cancel out because I moved them. I'm left with -4 times the radical equals -16. And the r's canceled out over here. Now, again, I see my radical. Now I'm down to a single one. That's great. We want to get that by itself. So we're going to divide by a -4. The radical comes down. -16 divided by -4 is a +4. And then repeat the process. Square it to get rid of the root. 9 minus r is going to drop down. 4 squared is 16. And this should be really easy to solve. Subtract the 9, that's 7. And then we have r equals -7. From here, you want to do your check. So I'm going to do the check over on the side. You're going to take what you got, plug it into the original problem. Okay, so my original problem was 2 minus the square root of 9 minus a -7 equals the square root of 3 minus a -7. All right, that was the original problem. I put in the -7 where it belonged in every r. Now it's just a matter of simplifying it. So 2 minus square root. 9 minus a -7 is 9 plus 7. That's 16. Square root 3, -3. So -3 minus a -7 is -3 plus 7. That's 4. Simplify your radicals. Square root of 16 is 4. Square root of 4 is 2. 2 minus 4 is -2 equals 2. That does not work. and I don't have any others to try. So that tells me that this -7 is an extraneous solution. Remember, an extraneous solution is a solution that works to the problem at hand, but not the original problem. In this case, I only had that number to check. Usually extraneous solutions we see with 2, but if I have a single term or a single value, and that's all I could check, I got close. -2 equals +2. It's the same number, but one's positive, one's negative, so it's not identical. This tells me I have no solutions. So if all you're left with is an extraneous solution that got you close, but not identical, you can have no solutions. So be aware of those as we're going through this. All right, our next problem. So the next one, we have on the same side are radicals. So I got to pick one. So I'm going to pick the first one. That guy's going to stay there. I'm going to move the other radical over. When you move radicals, you move them just like you would numbers or variables. You move the whole thing. You're not changing anything on the sign of the inside. You're just simply moving the radical. So it was a negative radical. I'm going to add the full radical. Okay, so that's going to get me square root -7 minus 4k equals 3 plus that radical. Okay, now my radical's alone. I can square both sides. Okay, insides will drop here. And in an effort to save space, I'm going to talk my way through this. Remember, it's a square, so there's 2 of them. So that means when I was to FOIL, I would have 3 times 3 and multiply the first terms. So 3 times 3 is 9. Plus, I would have 3 times the root, and then the root times 3. So there's 6 total of those, because I would have 3 radical plus 3 radical. So that's 6 of the radical. And then plus the radical squared. And again, we know that that square is going to cancel out. So we're just going to be left with -4 minus k. Okay, just like I did before, I'm going to bring everything over. That's not the radical. So I'm going to combine these. A 9 and a -4 is 5. So I would subtract it. I'm going to add the k over. -7 minus 5 is -12. -4 plus k is a -3k. And then we have 6 times this root. Going to divide to get the root by itself. You got to divide everything on the side. -12 divided by 6 is a -2. -3 divided by 6 is a -1/2. And then we have the root. So we're going to deal with some fractions. Don't be scared. Roots alone, so I can square it. And again, just an effort to save space and time. I'm not going to write out all the steps here, but we're going to multiply it by itself. So a -2 times a -2, that's a +4. -2 times a -1/2 k is a +1k. Then I'm going to repeat it because there's 2 sets of those, right? -2 times -1/2, and then I would do a -1/2 times a -2. So +1k, another +1k, that's a +2k. -1/2 k times itself is going to be a +1/4 k squared, and then -4 minus k. We're then going to bring everything over to one side. Anytime you have squares, we have to solve it by either the square root method or quadratic formula or factoring. So we need to get one side to be 0. So we're going to do that. As I'm bringing stuff over, I'm going to put it in standard form. So that means the 1/4 k has to come first. Then when I add the k, that's 3k. Add the 4, that's 8, equals 0. Now I want to get rid of that fraction. I don't want to deal with fractions. So I'm going to multiply everything by 4. Remember, you can multiply by the reciprocal. That will get rid of your fractions. This gets me a 1k squared, a +12k plus 32 equals 0. I can factor this. Factors of 32 that add to 12. are an x plus 8 and an x plus 4, right? 4 times 8 is 32. 4 plus 8 is 12. So we get x equals -8 and x equals -4. Now, just like we did before, we're going to have to check to see, does the solutions work? Now, when you're checking this, I'm going to move my head over here. When you're checking this, you got to go back to the original problem. So my original problem was when they were both on the same side. I need to check over here. So I'm going to start with the -8. Again, scroll back up here. This was my original problem. So I'm going to plug it into that. -7 minus 4 times a -8, excuse me, minus -4 minus a -8 equals 3, maybe. We'll see. So -7 minus a -4 times -8. Well, -4 times -8 is a positive 32. And a positive 32, and you subtract 7 from it, that's 25. -4 minus a -8 is a -4 plus 8. Well, that's 4. And then we have equals 3. Square root of 25 is 5. Square root of 4 is 2. 3 equals 3. That worked out. So I know x equals -8 is a solution. That's definitely one of them. We're going to do the same thing now, but we're going to check using -4. So -7 minus 4 times -4 minus the square root of -4 minus a -4 equals 3. Okay, so square root, first one. -4 times -4 is a positive 16. -7 plus 16 is 9. -4 minus a -4, so it's -4 plus 4, that's 0. Square root of 9 is 3, minus 0 is 3. 3 equals 3. So in this case, both are our solutions. I have no extraneous ones here. They both worked when I plugged them in. So takeaway from this, first off, make sure you get your radical alone and you don't do any squaring before it's by itself. And the second takeaway, you can have no solutions. We haven't talked about those in class, but if all I have is one problem, one answer to solve, to check, and if it doesn't work, it got me really close. So I know I did something right because there was a 2 and a -2. It's not like it was -2 equals 94. Then I know something really went wrong. But if they're close, they're similar, just different signs, and there's nothing else I can try, that's an extraneous solution, and there's no solutions to that problem.